So let's start by clicking on Game Object, 3D Object, and Plane. This is just to give us a floor to work with. And with the plane selected, we're going to come over to the inspector, and for the scale, we're going to make XB3 and ZB3. Just so we have a nice wide floor. Let's click on main camera. That's fine. Also, if you want, you can raise the camera up, and you can also say rotate it downwards. That way you've got this top-down view. In fact, I think I will raise this up a tiny bit. Okay, so now what we're going to do, we are going to create the portal objects. So game object, 3D object, and I'm just going to use a cylinder, and I'm just going to move this up vertically. Now, you can use whatever you want. You can make a custom 3D object. The object itself really doesn't matter, but I am going to scale this down vertically so it's thin rather than being a cylinder. So we're going to click on the scale. Let's select it. You can click on the scale tool, or you can manually change it here in the transform component. I'm just going to scale that down. Then we're going to take the rotate tool. We're going to rotate this up and make that -90 so it's perpendicular. And we're just going to click on the main camera. Okay, so can we move this a little bit closer? Let's also make this a little bit bigger. So for scale, we'll make this 2 and 2. And let's also make sure that it's not floating above the floor. It is. Wow, it's way above the floor. There we go. All right, so let's check again to see how that looks in the main camera. That's fine. We'll just slide it over. And actually, we're going to rename this first. We're going to call this Portal In. I'm going to slide this over. Let's check the camera again. That's fine. So what we're going to do right now, see how there's these circles surrounding it? That's the collider. So if you come over to the inspector, you can see there's a capsule collider. It used a capsule because it was originally a cylinder. Well, it's really a circle, kind of a flat disc now. So that collider wouldn't work because the collider is coming out and behind it. We really want it to hug the shape of the object. So what we're going to do is we're going to right-click and choose Remove Component from the capsule collider, Add Component, Physics, and we're going to do Mesh Collider, Convex, and Is Trigger. So it's hard to see because it's white on white, but there's the green collider perimeter is now much closer to the shape of this object. It doesn't always work if you have a complex shape, but it's pretty reliable. So what we're going to do now, and the reason why it's a trigger is you don't want a solid collision. You don't want the object, in this case it's going to be an orb or a sphere. You don't want it to bounce off of the portal or have the portal get knocked down. You want it to travel through the portal. So let's copy and paste the portal. We'll move this one over, and we'll call this one Portal Out. Now let's go to Game Object, 3D Object, Sphere. I'm just going to rotate around here to get a better perspective. And that looks about right. Okay, so the sphere already comes with the proper collider, but for us to move it, and I don't just mean move the position, I mean to roll it, have it travel, you need to add a rigid body. That way you can apply velocity, there can be gravity, that kind of thing. So with the sphere selected, you want to click on Add Component, Physics, and then Rigid Body, and we can leave all those settings. So now we're going to right-click, Create, C#, and we'll call this Ball Con, because it's going to do more than just roll the orb. So let's click on the sphere, add that script, just drag and drop it. double click to open it up. Now, if you haven't done any coding, this, wherever you see that double /, it's a remark statement. In other words, it's not executed. It's purely there for internal documentation. So you could just delete that and delete that. So it doesn't get executed. It's purely internal documentation. Now, the start section happens once, and that's when the object gets instantiated. So get component. Which component? Well, the component we were just talking about, the rigid body. We added a rigid body. Now we're going to modify it. We're going to apply velocity. New vector 3. X, it's not going to move. Y, it's not going to move. Z, let's have it move 3 along the Z axis. And 3, it's going to be moving away from us. We save this. The script is already attached, so this should work. And it's not going to teleport. We haven't added that yet. It's just going to pass through it. Okay. And now based on the shadows, I can see that these are a little bit high. So let's just lower these a tiny bit. But it worked exactly as we wanted to. If we hadn't set this to be a trigger, either this or this would have been bounced back or knocked around. It's a trigger, so it went right through it. Okay, so now we don't want it to travel through like that. We want it to get moved to this one. Now this is where coding gets a little bit, it's counterintuitive, because you would think the portal is moving the orb, but is really that the best way to do it? Because the two portals are really entirely different objects. So it doesn't necessarily make any sense to have the portal doing the moving. You can have the moving be attached to the orb itself, to the sphere itself. And again, that might sound counterintuitive because you're saying, but the portal does the moving. Well, from a functional point of view in the game, it may do the moving, but from a coding point of view, it may not make any sense to do it that way. So, we already have our script on the sphere, so we're going to have the sphere do the teleporting. Now, to teleport, we need to know where this is, okay? So when it collides with this, we need to be moved here. So this needs to be aware of that. So what we're going to do, in our script, we're going to do public transform, and it's going to be portal out obj. So when I'm doing this, I always try to append to the name something that indicates, is this an object? Is it a variable? That kind of thing. So this tells me it's actually an object. So if we save this, watch what happens. So we've got our sphere selected, portal out object. Well, here's our portal out object. So we're just going to drag it there. So for want of a better term, this is now aware of that. And now we can access various attributes of that, such as its position, which is what we want. So, what we want to do, we don't want this to happen at start or to update. Update happens once per frame. We instead want something to happen when a collision occurs. So, on trigger, enter. And since I'm using Microsoft Visual Studio, it pre-populated all that other text. Now this is referring to whatever object is being collided with. So because of that, I can now make certain checks. Like for instance, I don't want something to happen if I collide with this. I don't want something to happen if I collide with the floor, but I do want something to happen when I collide with this. So I can use the object name. And for those of you who are aware of tags, yes, I could create a tag, but in this case, there's no need to. The object isn't being instantiated. Well, let me rephrase that. The object is already in the scene, so it's not like this name is going to change. It's just that if you use an instantiate command, then it starts appending other words to the object name, like it'll be called portal in clone, that kind of thing. So because it's already in the scene, then what's going to happen is his name will be consistent, and you can check for the name. I just wanted to say that in case someone says, well, what about tags? Yes, you could use tags. So when the object that the script is attached to, which is the sphere, collides with a trigger, we want something to happen. Well, first we want to check to see if other.name, be good if I could spell, equals portal in, which is the name of the object, then we want something to happen. And again, it's not a coincidence that this is other and this is other. This, should I say, this is referencing that. So if the object that is being collided with, if the name of that object is portal in, then we want something to happen. Well, we want to move the orb. So get component, rigid body. Actually, if we're going to move it, let's use the transform, sorry. So we're just going to move the orb. Transform. So get component transform, and it's going to be new vector. Oh, sorry. Position. My apologies. So get component, which component? The transform component. Okay. Which attribute or aspect of that transform component? The position. Again, transform component position. So equals new. Actually, we're not going to do new vector 3. See how we grab this object? The reason why we grab this object is so we can extract its position. So portal.object.position. So when the orb, so the object the script is attached to, when it collides with another object, if the name of that object is portal in, then the object the script is attached to, again the orb should get moved to the position of the portal out object. Now that will work. Now what's going to happen is going to travel through, it gets moved to here, and then it's going to keep traveling, but you're going to see something. So a few things, you actually saw it come out on this side. That's one of the things that I meant, and it keeps going. So you could always tweak the position. So rather than using portal.position, portal out object.position, what you can do is you can break it down into its X, Y, and Z components and modify one if you want. We're not going to do it here because I want to keep this simple. But so it's been moved, but what if the portal is rotated differently? Because this isn't a great portal. You're going from here to here, big deal. You know, unless there's like a hole here or something that you're avoiding, you're really not accomplishing anything. So let's take this portal and we'll rotate this like 90 degrees. So when it comes out, we want it to say travel this way. Okay? So what we need to do, so in addition to moving its position, we need to now change its velocity. So here's what we're going to do. I'm going to copy this because I feel like being lazy. So when we move the orb, we're also going to change its velocity. What are we going to do? Now, this is going to look messy, but we're going to take its current z velocity and put it onto the x-axis. So there might be a slightly easier way to do this, but it works. Now this still isn't going to be quite right. So in other words, this should look familiar. It's just get component rigid body velocity. We already did this. But what we're saying is we're applying just the z velocity to the x-axis. That way, when it comes out of the portal, rather than continuing to move forward, it's now going to move to the right. But you're going to see something else that isn't quite right. So it goes through here. It goes out, but if you notice, it's actually going diagonal. It's not an illusion. It's not going nice and straight. And that's because something that's known as angular velocity, and you have to differentiate the two. There's forward velocity, or the velocity in whatever direction it's traveling, but it's also rolling, because an object might not necessarily roll. Like, for instance, if this object wasn't on the ground and there was no friction and it's moving forward, it might have an angular velocity, a rotation of 0. But because the angular velocity is separate from its forward motion, it's going on an angle. So what we need to do is we need to reset the angular velocity as well. Oops, sorry. Angular velocity. In other words, we don't want there to be an angular velocity. That for the briefest of moment, oops, sorry, that's angular velocity. I'm so sorry. Not angular drag. I thought I selected that. There we go. So angular velocity should be set to 0. So in other words, for the briefest of moments, we are going to eliminate any angular velocity. Now, when it starts to roll, it'll get angular velocity again. It'll just be different. So watch what happens. It's going to be subtle, but it's going to travel here. See? It's not diagonal anymore. So that's one of the things you have to be careful of is when an object is rolling, you have to differentiate between the velocity and the angular velocity. So where it's traveling along the world coordinates versus how it's rotating along its own axes. So that gives us the movement. Now, I do want to point out a couple of things. This is dynamic. So if we were to move the portal object, it would still work. So let's take this portal object. It still works. So that's good. This is static though. In other words, if I, for some reason, decide to rotate the portal a different direction, this would still be going along the x-axis. So in other words, we will eventually, probably in the next video, demonstrate how to dynamically take a velocity. So rather than having this be built in, we'll look at the rotation of the object and modify it that way. But like I said, this is fairly complicated to look at to begin with, so I don't want to get too complicated. But if you have, like, say, like maybe some golf games, like mini golf games, they'll have like portals. This would work perfect because those are static. They always face the same direction. So this will work. But like I said, if I do a second video, what we'll do, we will show you how to have, just as the position is dynamic, we'll also have the rotation be dynamic, which way it's facing. But that's for another video because the basics are in place. Now what I want to do is rather than having this blank object be here, and actually let's bring this one back. We want to actually be able to see, just as a portal, you should really be able to see through it, and you should be able to see whatever this is looking at. So let's look at how to do that. To do that is pretty simple. Basically what we're going to do, we're going to create a couple more cameras. The cameras are going to be positioned behind or just in front of the portals, okay? And that camera will have a feed into a material, and then the material will be on the opposing portal. So in other words, there'll be a camera here facing out. That feed is fed into a material, and the material is applied to this one because this is working as a view to here, just as this would be working as a view to there. So let's show you how that would work. So what we're going to do, let's go to Game Object, and we'll create a camera. We are going to take this camera. Let's rotate it, say 180. Which way is it facing? I don't think I got that facing the right way. No, so it's facing that way, so it wanted negative. Whoops. Oh, not negative 180, we want 0. All right, almost there. Okay, 90. There we go. So now the camera is facing to the right. So if we take this camera and we position it in close proximity to the portal, now we're going to have to tweak a few things, like so is that it's acting like as if the portal itself is doing the viewing. We'll probably have to tweak like the field of view and that kind of thing. But now what we do is we have that camera feed into a texture. So right click, create, and we need a render texture, and we'll call this out portal. And then we take our camera, we take out portal, and where it says target texture, we put it there. So again, we took a camera, we're feeding it into a texture, and then we're going to take that texture and we're going to put it on the other object. You can already see there's an image there. Also upside down. So what we can do, that's probably because I flipped this, I rotated it. So if we give this like a negative scale vertically, nope. Oh, I'm so sorry. I thought I had the portal selected. I'm flipping the camera. That's why nothing was happening. I'm so sorry. So portal in. So I believe we want. Nope, that flipped it left and right. That flipped it left and right. There we go. So now this portal, technically it's the camera, is acting like a lens for this one, which is what you expect because this is a portal, so you should be seeing what's on the other side. So what happens once the orb rolls through this and it appears here, you should see it here. Well, like I said, we might have to tweak a couple of things like the field of view. So let's just see how it looks when we do this. And there you go. Be creepier the other way if you see it approaching and it's getting closer to you here. And now you could just flip it so it's the other way around. So what you do is you can create another camera behind this one, create another texture, a render texture, and apply it to this one. If you want, I can do it, but again, it's the idea of rinse and repeat. Once you've done it once, you're just rinse and repeating and applying it to another object. So I think that brings us to the end of this tutorial. So you now can create these kind of semi-static portals because, like I said, if you move the out portal or the in portal, the portal will still work, but if you change the rotation, it does not. So I'm going to save that one for the next video. So I hope you found this helpful and have a good day.